What's up, algebra students? We're going to continue 9-4 today, which is completing the square, but this time we're doing it with maximums and minimums. So, good times. All right. So, essential question. How do I go from standard to vertex form? How do I go from standard to vertex form of a quadratic function? I don't have enough space here, so I'm going to have to try to fit it in here, which with this pen thing, I'm going to do quadratic func because I don't have time for that. And this is all funky anyway. All right, so this is something we've actually kind of talked about in the last chapter, this idea of converting between the two different forms. Hopefully you remember that with quadratic functions, you have standard form, you have vertex form, and there's also intercept form. And today we're going to learn how to go from standard to vertex and apply that to finding the maximum and minimum values, output values of the function. Okay, so before we dive in, let's go make sure we understand some of the, do some review here. Today we are going to convert from standard form to vertex form of a quadratic function. So which one has the A, B, and the C? So easy is 1, 2, 3. That is standard form, and we're going to convert that to vertex form. And hopefully you all remember the vertex is located at H, comma, K. And why are we going to do this? For a couple of reasons. Let's start with how this relates to the maximum and the minimum of a function. Okay, think of the function y is equal to x squared plus 6x plus 10. First, what kind of function is that? That is a quadratic function. How do we know? Because it has a x being squared, quadratic, and so the degree of the polynomial is 2. Quadratic function, its graph will be a parabola. So it's going to be that kind of U shape that we've already worked a lot on. Will the parabola open up or down? I don't know if you remember this, but the only thing that's in all of the forms of a quadratic function, all the forms have the same thing. They all have a. And a is the same number in all of the forms. If that a is greater than 0, then the parabola is going to be facing opening upwards. And what that means is that the parabola is going to look something like this, okay? So opening upwards. So it's going to open up. If a were less than 0, it'd be the unhappy face, right? It'd be opening downwards. So now let's think about the vertex of this. The vertex, which is located here, right? So the vertex is going to be at the bottom of the parabola. Now, what is a maximum and a minimum? A max and min is usually how we say those for short. When looking for a max or a min, you're really looking for the max or min output value. So what we want is the y value of the vertex, right? Down here, whatever this y value is, that's going to be the minimum if a is greater than 0. I cannot make a y. Okay, y value. Don't want to waste time there. Okay, so let's keep on going. Will x squared plus 6x plus 10 have a max or a min? It's going to have a min because a is greater than 0, so it's facing upwards. So the vertex will be at the bottom of the parabola. The y value of the vertex will be the minimum. When will a quadratic function have a maximum? When a is less than 0. If a is negative, then it will have, it'll be opening downwards and it'll be upside down, right? And so it'll have the vertex at the top. Okay, all right, we're doing great. Now, technically, y'all have learned how to do this, but we're going to use a different method. So, for instance, on this one, it says on the example over here, find the maximum or the minimum, minimum or the maximum value of y equals x squared plus 12x plus 40. First, is this a quadratic function? Yes, it's a degree 2 polynomial, right, for the inputs. And then the output's equal to that. So how did we find this before? Since the max or the min exist at the vertex, in standard form, we would do, remember, negative b over 2a, and that would give you the axis of symmetry, and then you could substitute that value into the function to find the output for the vertex. So if a is greater than 0, the function is going to have a, wait, it's greater than 0, that means it's going to face up, so it's going to have a minimum. And that's the best I can do, because the vertex is at the bottom. If a is less than 0, the function will have a maximum because the vertex will be at the top. Okay, we're going to try to now use completing the square. Instead of doing the negative b over 2a to find the vertex and then substituting that in to find the output, we're going to try completing the square. And by completing the square, the big reveal here is that completing the square allows us to convert from standard form to vertex form. Why? To find the vertex more easily, be real, you got this. See this? We could do negative b over 2a. We could, and find the vertex to find the maximum or the minimum. We could, but we're not. We're going to complete the square. And it's going to be really crazy, but you can do it. Here's how it works. I'm going to write the y over here so I have plenty of space, and y, which is my nemesis. Oh, I wrote it very well. Thank you very much. Thank you very much, man. That's pretty good. Okay, x squared plus 12x. Now, if you remember from the lesson for 9.4a, we want ax, or just x squared plus bx. This plus 40, we're going to leave it way over here. And now, if you remember correctly from that last lesson, we want to add a very specific number, which is going to turn this into a perfect square trinomial. But if we add that number, we're also going to have to subtract that number so that in total, we're adding nothing, because adding nothing doesn't change anything about this. So to find that number that we add and subtract, you take 12, you divide it by 2, right? You take the b, you divide it by 2, which is 6, and then you square it. That's 36. But if you add 36, you also have to subtract 36. And that whole time, the 40 is just hanging out here, not hurting anybody. So did we change anything? Well, we just added 0. So we didn't really change anything. But once again, what's the whole point of this? Because now this is a perfect square trinomial. And using that special product pattern, we can assume that it's a perfect square trinomial. We're going to now write this as quantity x plus, I don't know if you remember, this number here is b divided by 2. So 12 divided by 2 is 6 squared. X squared, right? 6 squared is 36. And 2ab, yes, I should say that's a squared, and this is b squared. 6 squared is 36. 2ab, 2 times x times 6 is 12x. Now we have this negative, or minus 36 plus 40 business. That's plus 4, correct? Whoa. Remember, if we had used the negative b over 2a, we'd have to figure out what that is. Then we'd have to substitute it back in and figure out what the y value is. Look how easy this was. We already know the vertex now. It's negative 6, 4. Why is it negative 6, 4? Remember, if it's inside the function, opposites, right? We must have substituted in a negative 6 in order for this to be plus, because the form has x minus h. Okay, so the minimum value then is 4. And where does it occur? And it occurs at, well, I guess it occurs at negative 6, 4, or at the vertex. Okay, so completing the square converts from standard to vertex form. Beautiful. All right, I'm going to make that part 1 in this video, and then I'll also post part 2.